Dear students, welcome to the next lecture of microcontroller. So today we will cover addressing modes. So let's proceed. So the addressing modes, these are nothing but a way to identify an operand in your code. Okay, so the 8051 has several, and we will examine all of these. So you know, operand means it is the quantity on which an operation is to be done. So earlier you saw that the basic format of any 8051 assembly language instruction is an opcode followed by an operand. Okay, so the example of an opcode is, let's say, move something to your accumulator, and then this is your operand. You are moving the hex data 55H, and this is denoted by this symbol here. So this part is your operand, and we are going to cover addressing modes in this lecture. So this is actually an example of one of the addressing mode, and you will know very shortly that this is called direct addressing mode, because the data is directly moved to the accumulator. Okay, so as I was saying, so addressing mode can be many. It can be a direct address of memory, or register names, or numerical data. So this is an example of a numerical data which is always preceded by this hash symbol. Okay, so you will see shortly that you can also use an address of a memory here, and how to move the data that is located in that address. You can also use register names. So this part you have also seen while you are writing codes. Let's say you are moving the contents of register R0, let's say, to the accumulator. So this is also another addressing mode. Okay, so these are examples of addressing modes where the data that you are operating on, either they can be a direct numerical value, or they can be residing in some register or some memory locations. Okay, and we will consider different ways to perform a simple data move instruction, and go through all the addressing modes. So the first one is the immediate addressing mode. So actually there are six or five, actually there are five addressing modes in your 8051. So they are as follows. So immediate, register, direct, register indirect, and indexed. Okay, and direct, register indirect, and index, these are basically concerned with accessing the data in the memories. And immediate and the register, these are not involved with accessing memories. Okay, so let's see the first one, the immediate addressing mode. Okay, so this is immediate addressing mode, the one with the hash symbol. So I just mentioned in this slide that this was direct, but this is not. Sorry about that. So this is immediate. Okay, rather this is immediate. Okay, this is not direct. My apologies. So so you have the first addressing mode, which is the immediate addressing mode, and this, as the example shows, is moving this data, which is a numeric data denoted by this hash symbol, to the accumulator. Okay, So this is the general way to write this. This can be any data preceded by an hash symbol, and this addressing mode is named as immediate because it transfers an 8-bit data immediately to the accumulator. Okay. Note that we have used the term datum here. So datum is singular. The plural form is data, okay, which we always use. So basically there are lots of data, so usually it's used in the plural form. In case you are confused with this term, this is the singular of data. Okay, so this is your immediate addressing mode. The hash symbol, as you all know by now, here indicates that the operand is a data. In its absence, whatever hexadecimal number you have would be taken as an address. Okay, so if you don't put the hash, let's say if you just happen to write this, so this 6a denotes in this case an address, okay, without the hash symbol. So whatever data that is residing in the memory, okay, in the address location 6a, okay, this data will be loaded to the accumulator if you write this instruction. So this hash symbol is important to notify that this is an immediate addressing mode. More details about the immediate addressing mode. So let's take an examples, the same example as in the previous slides. So you are moving the hex number 6a to the accumulator. The opcode for moving anything to the accumulator is 74H, okay, and it's a 2-byte instruction. 2 byte because 1 byte is for the opcode and the other byte is for the actual data that you are transferring. So the 2 bytes are 74 and 6a, okay. This is your byte 1 and this is your byte 2, and they are stored in the memory like this. So imagine that the data 6a is saved in the program memory 0203, okay. So the opcode 74 has to be in the previous location 0202, and then this 74 means that you want to move it to the accumulator, okay, and the actual data that has to be moved is 6a. So this 6a goes to the accumulator, and E0H is the address of the accumulator. So this space that is shown in this diagram is the accumulator actually, but the address of the accumulator is E0H. So this space, this 8-bit memory space which is reserved for the special function register accumulator, has also an address. So every space in the memory should have an address. We know it by the name accumulator or A, but this has an address E0H, okay. And in terms of the program counter, after this instruction is executed, the program counter which was initially at this location, the instruction, since it is 2 bytes, so program counter will increment 2 places after the execution of this instruction, and it will point to 0204, and whatever instruction is stored here, that will be performed next by the program. Then comes the direct addressing mode. So here, if you omit the hash symbol, then what comes is the direct addressing mode. In other words, basically this number is treated as the address location, and whatever is there in this address is moved to the accumulator. This happens to be, by the way, the address of the register 4 of register bank 0, okay. So 04 specifies to R4 of register bank 0. So if you recall, you have 4 register banks in your 8051, 0, 1, 2 and 3, and then each of them has 8 registers. Each of them has 8 registers from R0 to R7, right? So this one is the R4 of register bank 0. When this instruction is executed, whatever is stored in register 04H is moved to the accumulator. And here is the schematic of what is happening for this addressing mode. So in this case, when you are using move A with a direct addressing mode, then the opcode is E5. So notice when you are using move A with the immediate addressing mode, let's say if you had a hash symbol here, then the opcode for move A is 74 hex, as you saw in the previous example. But when you don't have this hash symbol, you use this instruction where this signifies the address of the register, then the opcode changes. So this opcode is E5. So for the same instruction of moving something to A, depending on what is your source, if it is actual data or if it is a memory address, the opcode changes. Earlier it was 74H, now it's E5H. It's still a 2-byte instruction with 1 machine cycle. So here if you assume the same memory space as in case of the previous example, so and this instruction starting from the same location 0202, so your E5 will be here and this will be the next byte of this instruction, and E5 means this has to be whatever is the contents of this location that has to move to the accumulator. Okay, so register bank 0 and then the 4th register of the register bank 0. So at 04H the control finds the data, let's say 1F, and that 1F, whatever was there in this 4th register of register bank 0, that is moved to the accumulator. Okay, so this is your accumulator, and as before this is a 2-byte instruction, so program counter will increment by 2 and stand in 0204. Okay, now let's see what is the next addressing mode, that is register direct. So this uses the register name directly as the source operand. So earlier it was using 04, but now it is using R4. Okay, and if you are using the register name directly, there is no way to know which R4 is this. Is it from bank 0 or bank 1 or bank 2 or bank 3. So for this you have to look into the RS0 and RS1 bits of your program status word register to see which register bank is active. If these 2 bits are 00, then it will be register bank 0. If it is 01, then bank 1, and so on. So so selection of register bank is via PSW, specifically the PSW3 and PSW4, or in other words RS0 and RS1 bits. So so this is the schematics of your this is the schematics of the PSW. Okay, so we have covered PSW before, so this is a revisit of the concept. So you have RS0 and RS1 here, which is the third and the fourth bit, and then based on these combinations you choose these register banks. And when you have this register direct addressing mode, you have this as you saw, and notice how the opcode again changes. You are moving to the accumulator, but now your source is the direct register name R4, and in this case it is EC. Okay, so in case of your immediate addressing mode, the same move A was using an opcode of 74 hex. In case of your direct addressing mode, it was using E5, and now for registered direct it's using EC. Okay, and here notice it's a 1 byte of instruction. Okay, because you are using the name of the register. Okay, so that is actually pointing to the data. Okay, it doesn't need to have another byte for the data or for the memory location. Okay, so you have 1 byte which is EC, that is sitting, let's say, at 0202, and it already knows that you are trying to move data from R4, because move A R4 has this unique opcode of EC. So whenever the opcode is EC, the CPU will know that this is basically to move the data in R4 to the accumulator, and then it will look for R4. So let's imagine that the register bank 0 is selected. Okay, and then the data from R4 of register bank 0 will be moved to the accumulator, and that data is 2F, so that is moved here in the accumulator. Okay, if register bank 1 is selected, let's say, then the data from register 4 of register bank 1 will be moved to the accumulator. Okay, and the program counter will increment 1 byte because it's a 1 byte instruction. So this means using register direct addressing mode can save program memory at the cost of using a register. Okay, so this is very important. So earlier you saw, especially in the case of immediate addressing mode, where you are putting a number directly like this using this symbol. In that case, it was a 2 byte instruction. In this case, it's a 1 byte instruction. So you are saving some program memory, but at the cost of using a register. So you have to store the data in the register, at least temporarily, to get it moved to the accumulator. So you have to use this register, which you could have used for other purposes. So there is a trade-off here. Okay, there is a trade-off between, let's say, saving program memory versus saving data memory. Okay, which one you would want? Okay, so depending on your choice on the application, you can opt for one or the other. Okay, next addressing mode is the register indirect addressing mode. So in this case, the address of the data is given in the register operand. Okay, so this is a bit more complicated. So this sign @ means that whatever is the number that is stored in R0, let's say this is your R0, okay, and let's imagine a random hex number that let's say A0, okay. This is the number that is stored in the register, okay, and whatever is stored in register R0, that is denoted by at R0 here, okay. So at R0 is basically this number, okay, and this number acts as the memory location. So in your actual memory you have different slots with different addresses, so whichever slot has this address A0 and whatever data is stored here, that will be moved to your accumulator, okay. So this is how you are using register indirect addressing mode. So here the value inside R0 is considered as an address of the memory location which holds the data to be transferred to the accumulator. And here is an important note here, only R0 and R1 are allowed to form a register indirect addressing instruction, okay. So you can only use at R0 or at R1. You cannot use an instruction like at R2 or at R3, okay. These are wrong, okay. If you use these in your code, there will be errors. If you write this in your quizzes, then this will be wrong and you will lose points, okay. So you can only use R0 and R1 when you are using register indirect. However, all 4 register banks are allowed, okay. So here is the schematic for register indirect. Again, note how the opcode changes here. So this will be 6. There is a typo here, so you have this in the 0202 location. It's identical to the examples before, and whatever is at R0, okay. So let's say assume that register bank 0 is selected, and at your R0 of register bank 0 you have this number 20. So this is the memory location, okay. So at 20 address location you have the data 2F, and this 2F is actually moving to your accumulator, and the program counter is incremented 1 step, okay. So so the next addressing mode is the indexed addressing mode, okay. So in this case, let us consider this example. So you have move CA, okay, at the rate A plus DPTR, okay. You could also use move CA at the rate A plus PC, so where PC is your program counter, DPTR, as you have known from your previous lectures, this is the data pointer, okay. So this DPTR, okay, and the program counter, these are the only 16-bit registers in your 8051. Rest are all 8-bit registers, right? So this means that at the rate A plus DPTR means that whatever is the value, that 16-bit value that is stored in DPTR, okay, that is added to the value that is stored in accumulator, okay. So DPTR value is 16-bit, accumulator value is 8-bit. So you can have a 16-bit number. Let's assume any 16-bit number, let's say in hex format F A0. Okay. And let's say the accumulator 8-bit number is um, F6. Okay, so you can add these two numbers, assuming that there is 00 here. And whatever will this addition, whatever is the 16-bit value, that 16-bit value will be treated as an address. So at A plus dptr performs this operation where this is your current dptr stored value and this is the current accumulator stored value. You add this and whatever is the addition here, okay, that number is treated as an address and you are moving the value stored in this address, okay, to the accumulator. Okay. For the time being, ignore this C part. Let's assume that move C just moves something to the accumulator. And what is that something? That something is given by this address. Okay. And this is the address. This is how the address is found, by adding the two numbers in dptr and accumulator. So so let's see how these things are done with an example. So move C means, okay, I told you to ignore the C part, but maybe you are curious. So move C means to move something from the code memory. So the C indicates code. Okay. So you are moving some data that is stored in the code memory. Okay. So move C is basically moving data to and from code memory. Okay. So we will come to the details of move C shortly, but right now just appreciate this much. So so let's see how this works. So I already explained slightly, but let's do it again. So move C at the rate A plus dptr, which is a 1-byte instruction, but it takes 2 machine cycles. So the opcode for that is 93 hex, and let's imagine that that opcode is stored here in this location. Okay. So let's imagine that my dptr, it's a 16-bit register. So the high value is 01 and the low value is FE. So 01 FE is added to the current contents of the accumulator, which is 02, and it will perform a 16-bit addition. Okay. So the 16-bit addition will give you 01 FE plus 02. So basically 01 FE plus 02 will be giving you this number 0200, this 16-bit number. Okay. So 0200 is the address from where my data will be moved. So 0200 is this address and my data resides there, and this data will now be moved to the accumulator. Okay. And since it's a 1-byte instruction, the program counter will be incremented by 1 byte. Okay. So this is the index addressing mode. Okay. So now let's discuss a little bit about move C. So as I said, move C moves a byte from code memory into the accumulator, and the code memory address from which the byte will be moved is calculated by summing the value of the accumulator with either the DPTR or program counter. So for both these cases we can use move C. The opcodes are different. For this one you saw that it is 93H. For this one it's 83H, and they are single byte instructions. So here is an example of move C, how it is used in a code. So let's say you are asked to move the word USA. So these are three characters here, U, S and A. So let's imagine that this word will be burned into the ROM locations starting from 200H, and that the program is burned into ROM location starting at 0. Analyze how the program works and state where USA is stored after this program is run. So first thing first, the program starts from starting location 0. So this is the starting location of the program. Okay. So when you were studying interrupt, you saw how you bypass this starting location and bypass the interrupt vector table, which is from 0000 hex to 0029 hex. Okay, so you bypass this location and start your program from 0030 hex. Okay, in this case we are not using interrupt, so we are starting again from 0000 hex. So it's totally depends on the scenario. Okay, so let's imagine that now that we have finished learning about interrupt, let's imagine that our code runs from the starting location 0000, and that's also asked in this example, starting at 0000. So starting at 0000 means that you have to use org 0000H, and then the other information that is given in this problem is that the actual word USA should be burned into the ROM locations that start from 200H. Okay, so let's say your DPTR is initialized at this location. Okay, 200H. So this works as a lookup table. Okay, so your data so your data is initially this is a bit confusing. So the initial data is starting from this location, or we have to write this starting from this location. That is not clear from this example, but nevertheless, let's say that okay, let's say you have okay, this part is the output of the programs. Okay, sorry about this confusion. Okay, so this is the part which will be after the code is run. Okay, let's analyze this code. Okay, so we have DPTR which is loaded with 200H. So this is the initial address. Okay, we are clearing the accumulator to 0, and then move C A at A plus DPTR means that you are adding 0 with 200, okay, and whatever is there in 200 memory location, that is brought to your accumulator, okay. So looks like in the 200 memory location you have this you have the starting location of USA. So USA can be divided into 3 separate 8-bit ASCII characters, U, S and A, okay. So at the first location, which is 200, you will have U, okay. So that will be moved to the accumulator, okay, and then you are saving that to R0. Then you are incrementing the DPTR, okay, so that then the DPTR is now pointing to 201. Okay, you are clearing A, and then you are doing move A at the rate A plus DPTR. So now you are bringing the data from the memory location 201 to the accumulator, and in 201 you have S. So S is moved to the accumulator in this line, and that is saved in R1. You again increment the DPTR to point to 202, clear the accumulator, and then perform this operation again to bring whatever is there in 202 memory location, and in 202 you basically have A, okay. So that will be moved to the accumulator at this line, and then that is saved in R2, and then you keep repeating, or you keep repeating this line, which means that you stay in this line, okay. So this is how you are basically using the move C to bring data from some location in the memory, okay. So data is burned into code space starting at 200H, which means the data is already staying in 200H, and you are bringing that data to the accumulator and finally saving it to the 3 registers R0, R1 and R2, okay. So sorry about the confusion in the beginning. So basically the word USA is already burned into the ROM location starting at 200H, okay. So the data was already there, okay. This part is the part of the code, this is not the output of the code. Your USA starting from U, S and A was already located in memory locations 200H, 201H and 202H, like this, okay, and they are finally brought to R0, R1 and R2, and finally these ASCII values in hex format look like this, okay. So your R0 contains this number, which is U, then R1 contains this number, which is S, and R2 contains this number, which is A, okay. Similarly, there is another instruction called move X, same as move C or similar to move C, which can move a byte to or from external memory into or from the accumulator. So you can have move X, whatever is here in the DPTR, or sorry, whatever is there in A, that can be moved to the memory location that is pointed by the 16-bit number that is residing in DPTR, okay. Similarly, you can bring data from the accumulator to the 8-bit address that is pointed by register R0. Similarly, you can do the same with R1. You can do the other thing, you can bring the data from the 16-bit address that is pointed by DPTR to the accumulator A, and you can do these things as well. So this is basically bringing data from the external memory, and that's why this X. Okay. For move C, it was bringing data from the code memory, and bringing and sending back both are okay. So basically to or from, into or from the accumulator, and this is true for move C also. And these are the different opcodes for these different cases, and all are 1-byte instructions. So one example of move X will be like this. So let's say you are asked to write a program to read 200 bytes of data from port 1 and save the data in external RAM starting at RAM location 5000H. Okay, so this is a sequential operation. You have to perform this on 200 bytes of data. So basically you use a count. Okay, so you are initializing the count at 200, and you are also initializing the starting location of the RAM as 5000. And notice how you are using these directives EQU, which you learnt about previously. So your DPTR is initialized with this RAM data, which is equal to 5000 hex, and your R3 register, let's say, is initialized with this count, which is 200. You are moving the first byte from P1 to A and sending it to the RAM location pointed by DPTR, currently that is 5000. Okay, then after some delay, okay, you are incrementing the DPTR. So now the DPTR will be incremented to 5001, and you are checking whether your R3 is 0. If not, then it's doing the same operation again. It's taking the next byte from port 1, moving it to A, and sending it to the current DPTR location. The current location pointed by the DPTR, which will be 5001 now. Okay. So then basically, let's say this is the part of the RAM where you are moving the data. This starts at 5000H. Here the first byte is moved. Next is 5001. Here the next byte is moved. In this way, you move the 200 bytes all from your port 1. And by making this arrangement DJNZ R3 again, where R3 is initialized to 200, you are repeating this 200 times so that you read 200 bytes from port 1 and store them sequentially in your RAM location starting from 5000 and then up to this location. You saw that there were some special function registers for your microcontroller. So all those special function registers, they have some names. For example, your accumulator is a special function register, but they also have some addresses. Okay, so you can use the names and also the addresses. Okay, now that you know about addressing modes, you can, and if you know the address of, let's say, the accumulator A, which is 0 is 0, then you can use that also in a code. Okay, Similarly for B register, which is another special function register, you can use the address of B register like this. Okay. So SFR registers have addresses between 80 hex and FF hex. So not all the address space of 80 to FF is used by a special function register. This should be kept in mind. The unused locations are reserved and must not be used by the 8051 programmer. Okay. So these are the specific addresses for different special function register. Okay. You saw for your accumulator, this is E0, for B, F0, for program status word register, that is D0. So everything has an address, like stack pointer is 81 hex and so on. Okay. And whatever is marked with an asterisk means that this is bit addressable. So let's do some examples to facilitate the understanding of these addressing modes. So let's say you are asked to write a code to send 55 hex to ports P1 and P2 using their names and their addresses. So you can do that using the names. So you can move 55 hex to A and then move the contents of A to P1 and P2. Or otherwise you can use the addresses of port 1. So from the previous table you can find port 1 is 80, port 2 is A0, so you can use them directly in your code like this. Next example is write a program to copy the value of 55 hex into RAM memory locations starting from 40 hex to 41 hex using the direct addressing mode, register indirect addressing mode, without a loop and with a loop. So so here you can do that. You can use direct addressing mode. Okay, and this will be a comma here, sorry for the typo. You can use the register indirect mode. Okay, you can use these symbols, and then you can use a loop also. This is like 2 consecutive locations. So for 2 consecutive locations in the RAM, it's not so practical to use a loop, but you can still use. If it is for more, let's say 10 locations, let's say 40H to 50H, then you can use a loop very well. So the main thing is that whatever is the total number of locations to work with, you load a register with that number, so that will be treated as your counter, and then you use dgenz that register to repeat the operations that you are doing. Okay, and the operations are moving the contents of A to the location that is pointed by R0, which is 40H, and then increment R0. R0 becomes 41H now, and then the same operation is repeated until R2 goes to 0. So this is a common template of code which you can run in a loop with some specific instructions that is getting repeated. Okay, so you initialize your code with the initial numbers loaded to different registers, and then you can repeat some instructions within a loop by this means. Okay, until dgenz R2, I mean, doesn't go out of the loop, and it goes out of the loop when R2 becomes 0, or I mean, you can use R2, R3, anything. You can use any register until that register goes to 0. You can repeat the loop. So this will be more clear from this example. Write a program to clear 16 RAM locations starting at RAM address 60H. So clearing 16 RAM locations starting from this means that you have to, let's say this is your 60H location, and then whatever 16 locations that comes after this, 1 2 3 4 5 6 and so on, you have to clear all these locations, or in other words you have to load them with all with 00 hex. Okay, so basically you are moving 00 hex, this number, to all these locations. So this is a repetitive operation of moving this number. So the template is same, so you are clearing A, making it to 00, okay, and then you are initializing the count, which is 16, and initializing the starting address, which is 60, by loading them to some registers. This can be any registers. In this example we have used R1 and R7. You can use R1, R2, R3, anything. And then the main operation is moving the contents of A, which is now 00 because you have cleared A, to the location that is pointed by R1 and repeating it until your R7 goes to 0. Okay, so you are moving A 00 to R1, incrementing R1. Sorry, you are moving 00 to the address pointed by R1, and then you are incrementing R1 so that R1 points to the next address, which is this address, and then you are repeating this operation until your R7 goes to 0. So you are essentially repeating it 16 times, and all these locations will be copied with this number 00, which is nothing but clearing the locations here. Okay, so let's look into the another example. So write a program to copy the value 68 hex to RAM memory locations 40H to 89H using indirect addressing mode with a loop. So again, you have to move this number 68H, so you are putting it in the accumulator, and your initial number is 40. I mean the starting location is 40H, so you are initializing this by moving it to R0, and then you calculate the difference between this range of addresses that you are asked to populate with. So you have this number in hex, so basically this is 73 in decimals, so you load that number to R2. Okay, you can move 73 in decimal, or you can move also 49 in hex, whatever. So you can write this line alternatively as move R2 49 hex as well. Okay, so then you do the same repetitive operation. So whatever is in A is moved to the address pointed by R0. Currently that is 40. So in the RAM location 40H, you will have 68H. Then R0 is incremented so that it points to the next location, which is 41H. And until R2 gets to 0, it will repeat this operation of moving the contents of A, so that will move to 41H, the same number, and so on. It will repeat until it reaches the location, let's say 89H. Okay, so this is how you can perform some repetitive operations using this register indirect addressing mode. Final example, write a program to get the x value from P1 and send x squared to P2 continuously. So so in this case we have applied a trick. So we have just stored the square values of the numbers 0 to 9 in a particular location in the memory, okay, and that location is labeled by this x squared table, okay. So all you need to do is to look up through this table and fetch the corresponding squares depending on what number you are getting from your P1. So we are assuming here in this example that we can only have the numbers 0 to 9 in P1, okay. But this can be more generalized, so this code is not so general. But just to focus on the application of your indexed addressing mode, I am showing this. So let's say you are initializing your DPTR with 300H. So 300H is the starting address of this x squared table, okay. So the x squared table starts from 300H. So at 300H, at this address you have 0, the first square number, 0 square. At let's say 301H you have 1. At 302H you have 4, and so on. So all these numbers are located at different memory locations starting from 300H. So now you are configuring your port 1 as a read port, as an input port, by moving this number 0FF to port 1, and then you are taking the number, you are getting your X from port 1, moving it to the accumulator, okay, and then you are doing this operation. You are using indexed addressing mode. So if your accumulator is let's say 0, let's say if your X is 0, okay, then your accumulator is 0, okay, and if you are doing @a plus dptr, you will get 0 plus 300 because your dptr is initialized at 300. So you will get this addition as 300, and @300 will give you the number 0 because 0 is stored in 300. So when x is 0, your x square is 0. That x square is fetched to the accumulator, and then that is issued to the port 2, and then the code is repeating again the same operation. It's taking the next number. If the next number is, let's say, 4, then 4 plus dptr, which is 300, will give you 304, and at 304 the square of 4 is located, so that will be fetched and brought to the accumulator, and then the accumulator issues it to port 2. So in this way the code will run by looking up through this lookup table, which is stored in the memory location starting from 300H, okay. So I'll stop here for this lecture, and this is the end of addressing modes. I'll see you in the next video lecture. Thank you.